In this video, we'll take a look at a situation where we have multiple stock in our portfolio. So instead of only having 2 stocks, we would have one more stock. So we would have 3 stocks in total. But then how do we calculate the risks and return for such portfolio? Suppose I have stocks A, B, and 3 with different expected returns here and different risks. And the weights are 20%, 40%, and 40% for the 3 different stocks. So the tricky part is I need 3 different correlation coefficients here. Why? Because if we have to pair the 3 stocks, I would end up with 3 different pairs. So A and B, A and C, and B and C. So we need all possible pairs to and use their correlation coefficient. So let's say it's 0.1, 0.2, and negative 0.5 respectively. Okay, so remember the correlation coefficient can only take values between -1 and +1. Okay, so how do we calculate the return and the risk for such a portfolio? So let's begin with the simple one, which is the return. So return for such a portfolio is still pretty much simple. And it's going to be the weighted average for individual expected returns. So the expected return for the portfolio is going to be 0.2 multiplied by 0.2 plus 0.15 multiplied by 0.4 plus 0.3 multiplied by 0.4. Okay, so basically these 2 columns, right? And then it should give me 0.22 or 22% as the average return for such a stock. But what about the risk for the stock? So whenever you have more than 2 stocks, it is advised to write or to draw the variance covariance matrix. Okay, so I have the columns and the rows. Okay, so I have RA, RB, and RC here in the columns and in the rows here, right? So what is the covariance between RA and RA itself? It's simply the variance. Okay, so since we have different weights, we need to add the weights as well. Okay, so we need different weights here as well. Right, so in this part, we would write WA squared and then variance of RA, or we could simply write sigma A squared. Okay, so what about this part? So what is the variance between the weighted return between the covariance between the weighted return of B and the weighted return of B itself? So it's simply WB squared sigma B squared, right? And then what about these parts? Okay, what about the rest of the diagonal position here, which is C? So that's going to be WC squared and sigma C squared. Okay, so on the diagonal here, as you can see, they're just the variances for the returns, but don't forget about weights as well. So what about the other parts here? Okay, there should be 9 different terms in total, right? Because you have 3 different stocks, so you will have 9 different items or different terms here. So in this case, you will end up with WA, WB, and the covariance between RA and RB. But we're not given the covariance, we're given the correlation coefficient, which is the row AB here. So I need row AB, sigma A, and sigma B. So similarly here, I need WA, WC, and then row AC, sigma A, and sigma C. And in this case, I would need WA, WB, WB and WC here, and row BC. Let's move it a little bit. Okay, and then sigma B and sigma C here. Okay, so what about this part? This part is the same as this part because they're almost symmetric across the diagonal here. So we can just write one more term here, which is WA, WB, row AB, and sigma A, sigma B. Okay, and the rest of it, you know how to do it. Okay, you know how to do the rest of it because they're symmetric across the diagonal here. So this will be the same as this part, and this will be the same as this part. So we'll skip the writing here. And this also explains the calculation or the equation that we had met in the two stock situation. Okay, so in the two stock situation, basically we only had these four items or these four terms. So that is how we got to the final equation or the generalized equation. So if you add these four terms up, you will get the same result. But in this case, we would have 9 terms to add up with. Okay, so if we plug in the numbers, because everything is known to us, right? I know WA, which is 0.2, WB and WC, which are 0.4 and 0.4 here. Okay, and row AB, row AC, and row BC, they're already given. Okay, so let's just write it down. Okay, let's just write it down. So I would end up with the variance of the portfolio being WA squared sigma A squared plus WB squared sigma B squared plus WC squared sigma C squared plus, okay, and then it's going to be a lot, 2 times, because of these two terms, right? They're symmetric across the diagonal here. WA, WB, row AB, sigma A, sigma B. Okay, and then plus 2 times WA, WC, row AC, sigma A, and sigma C. Plus 2 times WB, WC, row BC, sigma B, and sigma C. Okay, that's quite a lot, but then the calculation is pretty much very mechanical. So if you plug in the numbers, you should get 0.00992. And if you'd like this, the risk or the standard deviation, we simply need to take the square roots of the variance. Okay, so that should give us 0.0996. Okay, so that's about 9.96% as the risk here, right? So if we have multiple stocks, okay, if the question gives us more than 2 stocks, then it's advised to write the covariance variance matrix, just like this one, okay? And if you're very familiar with statistics, then you can simply write this thing as well, okay? If you can jump to the conclusion, then do it. If you cannot, it is advised to write down this matrix and pick up each term, each item here, so that you don't miss out on anything. Okay, so always remember the weights as well. Okay, it's not just the returns, but the weights as well. And then you need to simply add all these up. Okay, so this is the case for a 3-stock portfolio. So this is something you might run into in your exams or problem sets, but it's unlikely you would run into more than this. Okay, so as you can see, if we have 4 stocks, then we would end up with 4 squared, which is 16 different terms. So that's a lot of calculation, but that's going to be very mechanical. So it's pretty much meaningless if we provide you with like 4 or 5 stocks for you to deal with. But the essence here is that you know how to construct this matrix, because we'll use it to push the number of stocks from 2 to multiple, which is n stocks, and n approaches infinity here. Okay, and that's another topic for another video, and I'll see you in the next video.